Well, good morning, good afternoon, or good evening, depending on where you are in the country. We're just letting people join up. The numbers are scrolling up the screen, and I'm glad you can all make it. And we'll just give people a few more minutes. There's always a little pause when we hit the OK button. Off we go. And I need to also tell my computer, isn't it weird how Windows has all these ways of doing notification settings, and then it still ignores them and makes lots of noises come through. So I have to turn some of these off so that you don't get beeps in the background. Okay, well, I think we're reaching a limit of people coming up, so we'll start going. Speaking to you now is Ian Barker. I'm the developer advocate for Embarcadero, and joining me later for a live Q&A, and in fact he will be behind the scenes all throughout this, is David Millington, who is the senior product manager, for Rad Studio. The presentation today is pre-recorded, but we will be here live as well answering your questions. If you've got any questions, you will see them in the chat. If you just type them into the chat window, and we'll answer them as we go along. And then the ones that we can, we'll actually address those at the end in the live Q&A as well. If we're all ready, I think I will start the video and we'll see you.
Hi everyone, Dave Millington here. I'm a Senior Product Manager here at Embarcadero, and I look after C++ Builder. This is the second Behind the Build webinar. It's what will hopefully become a series where we take you behind the scenes and show you a lot more than we normally do. We don't normally speak much about what's coming until it's released, but these webinars are a great opportunity to speak more freely, to show you what's coming, and because it's unfinished, show you what works, what doesn't work yet, and more. And we're going to show you some things that aren't complete yet, and a lot of things that are complete and are pretty amazing. That said, this is our standard disclaimer. Please read it. While the exact text on screen is the text that applies, in effect it says that nothing you see here is a promise. Nothing is committed in any way until you see it actually shipped. We need to give that caveat because it lets us speak more freely about what we're working on, because it's clear that this is not a promise in any way. You're software developers and you understand why. So with that said, we held one Behind the Build before last August. That's August 2023 for those watching in the far future. And in that we previewed Visual Assist integration, which made it into the 12.0 release in November. We have a lot of quality work on that coming in 12.1, by the way. And we also previewed the Clang toolchain. That one only made it into 12.0 as a preview, because it wasn't ready yet. The compiler and toolchain is a major rework of our technology, providing all the C++ Builder extensions and features you know and rely on top of and extending a completely new compiler and technology. It's been a really substantial effort, one supported at every level of the company, and I'm very grateful to all of our staff and executives for doing that. One thing we've done is take the approach of ensuring we do it right, and that applied in November. Now, obviously, we would like to ship earlier rather than later, but in November it was not ready, so rather than crunch, we shipped a preview, which gave you access to the toolchain for pure C++, i.e. without the VCL or FireMonkey or our extensions, but where you could test the debug format, the STL, and so forth. What you see on screen is an approximate list of what goes into a full C++ Builder compiler toolchain. I'll get into each one of these in detail during this talk, but essentially this means that in November, we had the plain C++ parts hooked up, a new STL, a new C++ runtime, the debugger could debug, although minimally it didn't have as full support as we have today, and so forth. But a lot was missing, or rather, it was there behind the scenes but incomplete at the time, so we didn't enable it in the preview. We let the preview focus on the quality of the plain C++ side of the toolchain. What we have right now, in February 2024, is a whole lot more. We've finished work and connected up a lot of the key parts that make a C++ Builder compiler a real C++ Builder compiler. These are all enabled and working in our current builds. So this is a really nice chart with lots of green check marks, and to be honest, I'm very excited by the entire thing. Let's take some time and go into each one of these areas in detail. I'm going to explain what each item is and why it's needed and why it's useful to you and how it works. The first 4 slides here cover the C++ fundamentals, and so it's similar to what we saw in November, although some things have changed, because they overlap what we shipped as a preview. But I want to go over them anyway, so people who are new to the work we're doing know what we're doing. And if you've seen us discuss this project before, please stick through the next 4 slides, and then we'll get into something completely new. A toolchain is a lot more than just the compiler. There's the other tools like the linker and librarian, the underlying object file format, and more. But we'll start with the compiler because it's the front, it's the part that you generally see. Our goal for this work is not just to provide an updated compiler, but a robust, high-quality toolchain following as many platform conventions as possible, as compatible as possible. Originally, and this is a year ago, we had hoped to use the same ABI as Visual C++, the binary representation at the object file level, because it's the de facto Windows C++ ABI, plus the open source MSSTL, for compatibility reasons. Now, there are no C++ standards on Windows or platform-defined STL the way there are for other platforms, but all the work we've done is to follow the de facto Windows standard where possible. That's one reason, not the only one, why we're using the COF object format, for example. Instead of the Microsoft ABI, we're using the Itanium ABI, which is a very widely used and known ABI for C++. That's mainly because there are closed source aspects that affect the Microsoft ABI, so we would have been pursuing compatibility with something not fully available. It's better to use a well-known C++ standard, even if it means we aren't fully compatible with the Microsoft way of doing things. Now, the ABI is the internal way at the binary level how data is represented. There is the platform ABI, something like how a calling convention works, but there's also the C++ ABI, which is how a name is mangled, the data layout, how constructors and destructors work, and so forth. The Itanium ABI is different to Microsoft's ABI. The mangling is different, as is even the number of types of constructors. None of the C++ ABI affects the final linked binary in terms of function, in terms of what it can do, but it does affect how the compiled code is represented, so it affects things like linking. It can also affect things like compatibility with Delphi, and the Itanium ABI is the right choice there. Now, most of this doesn't matter exactly, but it is interesting if you're interested in this sort of thing, and I mention it because this is the kind of webinar that shares these tech details. The parts that do matter are areas that we've worked on. For example, we've ensured that the standard object linking pragmas you're used to work. They were not there by default, which is not due to the ABI specifically, but due to the compiler and RTL heritage, though they're related. Effectively, the takeaway is that you have a compiler that understands the existing code in the C++ builder's specifics, which of course is what you need since you have existing code. You want it to work as expected without modifications when upgrading. That's what we've got, at the same time that we have a toolchain hugely more similar to the de facto conventions used on Windows. And that means what other tooling not made by us expects and can work with too. In other words, full C++ builder compatibility along with compatibility with other tools as well. The one thing to note is that we're sometimes asked if object files or lib files compiled with Visual C++ will be able to be linked in directly, or combined with, object files compiled with our compiler. Look, there isn't a C++ compiler in the world that can directly link in object files from a completely unrelated compiler. Every C++ compiler is different, and is ABI incompatible. But the fact that we use different mangling, a different STL, and that means a different binary representation when it's compiled, the libc++ vector is different to the Visual C++ vector at a binary level, so you can't link in two different implementations of vector, and so forth, means that no, you can't link in a VC++ object file directly. We might get there one day if all of Windows C++ becomes open, the way it is on Mac or Linux. We're aiming at source compatible. We're aiming at the C++ and platform standards, and any C++ file that someone compiled with Visual C++ or MinGW or other Windows C++ toolchains, you should be able to compile with C++ Builder too. I'll go faster here. The C and C++ runtime provide the underlying layer for the STL in your code, provide file I/O, exception handling, and so forth. Following our goal of using the Windows conventions where possible, we're using the Windows system component, the Universal C runtime, and our own C++ runtime based on MinGW, but heavily extended. In previous webinars I've talked a lot about exception handling, so I won't now, except to note it's solid, really solid. Now backwards compatibility is important, and we work hard on ensuring any app that built with a previous version of C++ Builder either directly works or has very obvious changes. But here's one exception. We are not carrying forward RTL functions that were originally from Turbo C. Turbo C for DOS dates from about 1987, and Turbo C++ ended in about 1995. They predate C++ standardization, the first version of which was in 1998. Now those methods all have replacements that are part of standardized C++ or part of our own Delphi RTL, and if you happen to use any of them, you'll find a replacement very easily. For example, instead of using a method random, use stdrand. But this is behind the build, and we point out everything. If your code uses RTL methods from products that entered in 1995, and I phrased it that way to make a point, but equally, it can be hard to know the original source of code, and if you're using something, it's completely fair to keep using it. And even if you happen to know that you were using old non-standards compliant methods, if your code kept working, there is no reason for you to have changed it until now, so it's very valid. But we had to make a call in terms of ongoing maintenance and standards compliance, and we decided not to support non-standard methods from 3 decades ago. Now so far, in all our testing, we've only encountered 2 apps which used 2 methods and 1 header. And it, and everything else, including things that we haven't found yet, no matter what it should be very easy to replace and update. And it's pretty unlikely that your code uses very much, if any, RTL methods from Turbo C. But here we are, standards compliant RTL, no Turbo C legacy. The standard library, the STL, is the part of the toolchain where our implementation starts really affecting your code. So this is important. Our previous STL had some quality issues. This one is much better. All the previously problematic areas, like variants, for example, of the old STL work well here. Something like 6 months ago, we already had far more compliance tests passing than our old toolchain, and of course we've only got better since then. I've noted we're going to upgrade Clang once we've shipped, but you can see what we support listed in the libc++ documentation on the LVM website. Anything marked version 15 and earlier should be what we support. The STL and our compiler do support a large portion of newer C++ standards. It's unsupported by us right now, but you can try using the stud equals C++ 20 or 23 flag and try using things like span. And the linker. This is one of my favorites because our old linker had issues, especially with large codebases. Our new one is modern, fast, capable, and can handle huge amounts of code. This linker is the one used to build Chrome. So if you're a customer who is constantly tweaking iLink's memory flags to achieve a link, just switch. Just use the new toolchain. Also, and this is preliminary, testing shows it links about 4 times faster than iLink too. Now this is behind the build, and we're talking about things we're still working on. So, right now we're looking at generated code size. If you compile with optimizations with level 2 optimization, O2, often you get a much larger binary, generates a lot more code in the output file. The optimizations for speed often make the compiled code larger. There are strategies to solve this, and we'll likely turn one of the 3 on by default, which is linker garbage collection, or removing sections the linker knows are unused. Now, function and data sections, the other 2 flags, will be present in our compiler options but off by default, because they can sometimes cause your compiled app to run slower. But they will be there if you want them. Okay, so that's roughly where we were in November, with a few tweaks and extensions in the months since. Where are we 3 months later? Now let's look at the bits highlighted in red here. The debugger. In 12.0, when we shipped the preview, we had 2 Win64 debuggers. One of them was normal Win64 debugging, but the other was for the preview toolchain in 12.0. And using the preview, you could debug from the IDE, but not yet do things like evaluate complex STL types in a readable form, because we didn't have formatters. Formatters are like debug visualizers. They're Python code snippets that run and turn complex internals of a class, like an STL object, into a more human-readable version. But now, we don't have two debuggers anymore, we've unified them, and there's just one Win64 C++ debugger for both the old and the new Win64 C++ platforms. They use the same debugger now. And you can compile and run from the IDE, we'll get onto that in a moment, and there are formatters for the STL collections and for our Delphi types like string. And of course, you can do things like evaluate properties, one of our extensions. In other words, it's got everything we need. And the IDE. In November, you could use the Run Attach to Process menu to attach and debug, and that was it. So what have we got today? Everything. You can compile and run and debug from the IDE exactly as you expect. In fact, I'll show you this in a few minutes. Now, some specific things to call out are that in the old days, i.e. for every toolchain, including Delphi, so everything before the new Clang, we had a DLL version of the compiler. That meant the compiler was limited to a 32-bit address space shared with the IDE, so limited memory. Plus, Clang these days is not really designed to be built as DLL, so it required some hacks, especially for newer Clang 15. Well, hacks are not what we want, and 32-bit is not what we want. The IDE integration now actually uses external binaries, i.e. calls the compiler as an exe file, and it's very likely that we'll ship the binaries as 64-bit binaries too, with the massive address space that implies, which is great for large projects. For various reasons, mostly related to legacy moving away from 32-bit DLLs, we were still using 32-bit builds of the compiler. We toggled them over to 64-bit a few days ago, and so far all tests are passing, and hopefully that's what we'll ship. The other thing is the virtual file system. What is that? Well, you might have noticed that when you create a new project, you don't need to save it to disk to compile and run. Or you can modify a file in the IDE and run, and the unsaved changes, in other words, changes in the editor but not on disk, are reflected in the compiled app. And this is the virtual file system, in that the IDE provides a file API so that its tools get the file contents from the editor if they're different to what's on disk. Now, this was semi-straightforward when we used DLL for the compiler loaded into the IDE. But how does that work when it's a separate process completely? Well, it uses the Clang VFS, a system that works differently but achieves the same thing. And then, of course, we have the big items, the actual main important part for you with your apps, which is, can we compile VCL and FireMonkey apps? And yes, we can. The screenshots here are from one of the FireMonkey apps on our GitHub and the Skier C++ demo, and it's a big move from November. VCL and FireMonkey apps are working. So let's have a look. We've had lots of slides so far, so let's dig into the IDE and see this in practice. So this is an internal build of the IDE. I have one of the C++ apps on our GitHub open. It's one I commonly use for demos because it's lightweight but complex enough to be a real app. It actually does something, it's not just a demo. Notice over here in the projects view we have two Win64 platforms, Win64 and Win64 Modern. Now, the naming isn't great, but we haven't thought of a better one yet, so Win64 Modern is the new upgraded compiler. And we quite literally have both here in parallel. And if you have a project with a Win64 platform, you can just add the new Win64 Modern to it and toggle between them. That makes upgrading very easy. You can toggle between the old and new and build with both. So let me compile this. Note that the compile dialog is there, but it isn't giving a line count. That's the result of using the external compiler and isn't fixed yet. A line count is minor. It's a long way down our priority list. And also dragging it is a little laggy. And it's also a long way down our priority list. That's the kind of thing we can change later. We are focusing very heavily on the core and getting the technology working right for you. If I place a breakpoint, you can see the call stack over on the left, a series of 64-bit addresses and methods. If I look at the neighbors variable in the local variables, which here is a vector, you can see that I can see the elements printed nicely. It has one element currently, which is because we have a formatter for this and other types now. And if I look in more detail in the evaluate dialog, you can see it's showing the contents of the cell type at element 0 as well. There's no formatter for that one, it's a custom type for this app, so it shows all its fields and so forth as you'd expect. The takeaway here is that we have visualization for the complex STL types in the debugger. They're easy to read. This is a behind the build, and here we talk about behind the scenes and what's not ideal yet as much as what is. Now you might have spotted that when the breakpoint hit, it took a few seconds to show the local variables in the call stack. And debugging can currently be slow. Why? Because we're running the formatters too much. Remember, format is a Python code that's run by the debugger to present things in a more pretty form, and we're currently invoking that Python code too often. So we have a to-do, we need to identify why they're being called so much and cut that down. Now formatters are incredibly powerful, and you can write them for your own data types too. Now let's delete that breakpoint. If I open the main form, and this is a wide screen, so let's make good use of that horizontal space. Here is an event handler for a text field. If I place a breakpoint here and then run, and trigger a key press event in the app, when it breaks I can evaluate the edit and an expression using a property, here the text property. So you can see that things like properties, which are a custom extension, here evaluating a Delphi implemented property from C++ is fully working. And if I open Task Manager and rebuild, you'll be able to see BCC64X, the new compiler, being invoked by the IDE. Note that it's a 64-bit binary, and that means an immense address space. And just yesterday we started seeing the benefits where one code sample we'd been given was validated by our QA as compiling now. It was complex and used too much memory in the 32-bit builds, but it works fine now that we're using 64-bit compilers. And if you have complex code, or use complex libraries, this will be a great benefit to you. So let's get back into details. All the Delphi components, VCL buttons and REST and FIDAC and so on, are in packages. Currently, we're building and testing the core packages, the core set of components in RTL, which is the entire VCL, the entire FireMonkey, Skier, the core RTL, including REST and live bindings and a bunch of networking and internet and a lot of database components, including all of FIDAC. We're currently not building the much smaller list you see on the right, and this is to keep our test matrix down. We're focusing on the core, VCL apps, FireMonkey apps, runtime, networking, database, that sort of thing. And if you see something on the right that you depend on, let us know, we can test with it. And just because it's in the yellow area doesn't mean that you can't use it. We ship most of our source, you can always add these yourself. It just means they're not part of our core that we're testing and shipping right now. We only have a couple of in-depth slides left. First, Delphi interop. Now, all our components, the VCL and so forth, is written in Delphi, so since we have VCL and FireMonkey apps, it's clear that we have Delphi interop working. We, and soon you, can build VCL and FireMonkey apps, console apps, DLLs, and static libraries. Delphi interop is optional for the last few. You can build those as pure C++ without the Delphi runtime if you want. Everything you expect is working. You can use Delphi types, write classes in C++ that inherit from a Delphi class, and so forth. One notable difference is the memory manager. When you compile a Delphi app, by default you use fastmm to allocate and free memory. When you use a C++ app with a new toolchain, and this includes Delphi code that's linked in to your C++ app, we're using the Windows UCRT memory manager. In other words, using the same one that the vast majority of other apps on Windows use too. Now, we actually really like fastmm, but the UCRT, which is our new C runtime, the platform C runtime, doesn't have the same ability to hook memory management the way the Delphi runtime does, so we have to use the Windows standard. However, we figure if it's good enough for every app and game and performance software built with Visual C++, it's good enough for us. On to packages. So we saw earlier a list of the packages we're building and testing against, the ones containing VCL components, REST, FireMonkey components, and so forth. Packages for C++ are usually either a BPL file, which is dynamically loaded like a DLL, or a static library, a lib, which is statically linked into your app. Now, this is a behind the build where we talk about what's not working yet just as much as what is. So let's see something that's not finished yet. And that is the split between static and dynamic packages. First, static linking to packages, where they're linked directly into your exe or DLL or whatever, is working today. The VCL and FireMonkey apps you saw earlier are statically linked. Dynamic packages, i.e. BPL files, aren't yet loaded dynamically. It's planned to have dynamic packages, of course, so you can expect it soon. This effectively makes our current builds of C++ follow the Delphi default. Delphi statically links by default unless you change it. The main reason to dynamically link is for link speed, and also because our old linker struggled with large linking, so you gave it as little as possible. Unlike Delphi, the C++ default of dynamic linking has been a default specifically because of link time, since 1999 or so. But since our new linker is 64-bit, is the same linker that handles linking Chrome and can handle giant links and is about 4 times faster than iLink, statically linking is much less of an issue. And as I said, we'll address it soon. We're still unsure what will ship, but this is where we are today. One very rare use case is to create packages with C++, C++ code. Now you can do this as static packages to link in statically, which is fine, but because we're not consuming dynamic BPLs, we're not building them from C++ yet either, and that will come too. So here we are. That is the current state in February 2024 of the new Clang toolchain. Miles ahead of what we previewed in November. It's not just the new runtime, the new STL, the new linker and so forth that we can talk about, but full IDE integration. We have VCL and FireMonkey apps. We have all the Delphi interop you expect. We have debugger evaluation of our extensions. We have linking to packages statically and a couple of things that we're still working on. You can see overall, wow, this is in great shape. It's very high quality, a lot of both specific quality and robustness work and very good numbers on our test suites. It is hugely better than the previous toolchain. And there are many parts of it, like the STL alone, or the new linker alone, or the 64-bit binaries and memory space alone. So many things that we think make this an incredible upgrade. Or the platform compliance, the Windows C runtime, or the usage of PDB debug info for using other tools, so many things. We're hoping you'll see this and move over immediately, just the increased stability should help. And of course we've made moving over easy, because we have the old and new platforms side by side in the IDE, so it's as easy as toggling, a double click to move from one to the other. That's about as easy as migration gets. And on that very positive note, because I really want to communicate how we've taken our time with this, have not rushed to ship, but waited, taken time, done it thoroughly. We think this is an incredible thing to be delivering to you. Before I became the product manager here, I was a C++ Builder user, and this is the toolchain that I wanted C++ Builder to become. I'm very proud of it. I'm very pleased with it. Our engineers have done great work, and I'm really glad about what we're delivering, and glad about what it means for C++ Builder now and in the future. And on that very positive note, C++ Builder celebrated its birthday just a couple of days ago on February 26th, and this is a very nice way to celebrate it, seeing some amazing things coming very soon for the product. And with that, let's open to a Q&A.
Well, hello everyone, and we should be back. Let me just make sure I'm showing my screen, which I think I am. Let me check my little previews so I don't get it wrong. Show my screen. There you go. Go to webinar. It's one of those things that takes a little bit of getting used to. Okay, well, the good news is we've got a couple of people live with us. One of them is David, who you just heard describing all the features that we're looking at the moment. And also joining us as well is Kyle Wheeler, who's the general manager. So hello, guys. You're currently muted. So I think we'll turn our cameras on.
Can you hear me?
Hello.
Yes, we can hear you fine.
All right. Awesome. Thanks, David. Thanks, Ian. I just want to say a few quick words. As David noted here, this is a huge step forward for us, and it's foundational to what comes next. I know there's several questions here in the chat that we've answered as far as what the future looks like. And I'll say it again, that future depends largely on the ask from you all. We are in the process right now, actually, of working on a pretty comprehensive C++ focused survey that's not only for existing C++ builder users, but more broadly to be distributed, just to see what direction we should go in, what things are both table stakes for current development, and then what people are wanting to do in the future. And because of this foundational work, we're able to actually execute on that much faster. So we're excited about that, but we will be sending that survey out within the next, I believe, the next week as a follow-up to this webinar, and then also to, again, a broader audience. So really appreciate your attention and time on this webinar, but hopefully on the survey as well, so that we can catalog those responses and act accordingly. So, and again, as we often say, we're pretty open door here in terms of our ability to have separate conversations with you all. So if there's a project looming, if there's something on your radar that you really want your voice heard on, please reach out to us. David, Ian, myself, we're all available along with other PM members as well to just discuss what you're up against, your clients, the applications you're building, the things that you need, what you need from us, and we're here to listen. And we are, like I said, we're working right now on towards the future of C++ Builder and the IDE as a whole. So we're excited to hear that feedback and open to listen to you. So with that, I don't know if Ian, if you want to take us through some of the questions to call out, or David, I'll leave it to you guys.
I'm gonna see if I can turn the camera on. Yeah, I don't know why, but my cameras aren't showing up. So there you go. We'll just go back to sharing the screen again.
Yeah, and I'm having the same problem. I can't turn my camera on either. So I think
it's go to webinar. It's go to webinar. I don't want to be horrible about it, but I hate it. Anyway, so that's the tool we're using. Look, you'll just have to imagine that we look all very svelte and dressed up in our suits and ties and things like that, and not in the t-shirts that we're all wearing. Anyway, thanks, Carl. One thing that I wanted to call out as well, which kind of goes along with what Carl was saying about outreach and wanting to hear from you, and it was something that you brought up in the video actually, David, which is you said before you became the product manager that you were a fan of the product, and actually that's something very true of a lot of us, me included. I've been a Delphi user since day one. Don't use C++ Builder very often, but I do use it from time to time because that's how it works. But nearly everybody that you come across in the company who is some form of developer, and not everybody is obviously, but either has been a developer or is a developer, they're all really big fans of the product, and that's what I think makes us unique, really, or special, that we actually do really believe in these products. We're very passionate about them, and so people like David and myself are always very, very keen to show you all the new cool stuff, because it's cool for us too. These features that get put in there that we're trying to bring out, and again, just remind you about the safe harbor statement, where we do have some legal requirements to not just make promises which we can't keep. So we're trying to show you what we believe is deliverable, but bear the safe harbor statement in mind. But those kind of features we find exciting ourselves as well. And I just wanted to kind of drop in on what you're saying. David, do you want to call out some of the questions then, and that you particularly noticed?
Sure. Look, we had a huge number of questions actually, and I'm still frantically typing, so I will stop typing and start on moving on to them. But look, questions are wonderful. I mean, it's fantastic to get them because it shows how excited people are. Yeah, look, let's just start at the top. Where are we? So yeah, there's a question here about if this is referring to 64-bit Windows only or 32-bit. So this toolchain is currently compiling for 64-bit Intel, 64-bit x86, I guess, or x64. Once we ship this, we're considering what platforms to go to after that. And there's a similar question as well about Android. And look, the new toolchain is a foundation, really. It's a lot more modern and a lot newer, a lot up to date, handles the newer C++ standards better, and all that kind of thing. It's a foundation that we can build on, including for other platforms potentially. Right now, we're just looking to ship this. We think it's one of the best things ever for Windows developers. And after we ship it, we're going to be looking at where we can go forward after that.
Yeah.
Had a couple of questions. Oh, sorry, Ian, you were about to say something?
No. I was just agreeing with you and saying yes, exactly.
Cool. Yeah, look, we had a couple of questions about compatibility with Visual C++. Look, I tried to answer this in the webinar, but I know it's a complex area. So a year or so ago, when we sort of posted our blog about the goals for this project, we were hoping to use a lot of the sort of Windows standard things, which effectively is Visual C++ standard, because Microsoft both makes Windows and makes Visual C++. But some of the key stuff there is closed source, and we don't have access to it. So what we're aiming at is source compatibility. Effectively, we want to have a really good compiler and a really good toolchain that can handle whatever you throw at it. And so if you have a random C++ library that we have never looked at and never tested with it, that might compile with Visual C++, it should be pretty straightforward to work with C++ Builder. We want to make sure that if Visual C++ can compile something, we can compile something.
Yeah.
Let's see.
Saw a few questions about.
I apologize. Go ahead.
Yeah. There's a little bit of a time delay between you and I, and it's that's a bad thing with me because I talk too much anyway. But one of the other things as well was there was a little discussion on one of our boards, but it's come up a few times, and that is the description of modern when it comes to the compiler, because we just need to clear up what we're talking about there. The difference really, and if you're a C++ programmer, this will make sense, is the difference between ELF format and COF format. And COF, I believe our current terminology is modern, in that we are saying that that's the modern compiler. It is similar to the idea of modern C++ in the sense that the C++ standards have a concept of modern C++, which is not necessarily the same as what we would call modern in terms of the compiler. So, when you get on that target and you select which type of compiler you're going to use, one of them says modern at the moment, and that's the COF format. Am I right in saying that, David, or have I misunderstood?
Yeah, so we currently have two Win64 platforms, and as I showed you can just toggle between them. And yeah, the idea is there you can just open your existing projects and just add the new one and just go back to the old one to check something and go back to the new one to rebuild, and that kind of thing. Yeah, look, the new one is currently called Win64 Modern, and I don't think that's a great name, and that's my fault because I was the one who named it. I had trouble thinking of something better. And yeah, look, maybe we'll give it a better name by the time we ship. The reason we call it modern is look, it's not just about switching from ELF to COF, but it's also about the approach. It's a much newer compiler, so it can handle a lot more stuff, can compile a lot more C++ libraries that are out there. But we also have an approach that's different. We really focusing on just doing things following Windows platform conventions and that kind of thing. We in the past we have sort of done things our way, but we questioned with everything. We questioned all our assumptions with all of our technical decisions when doing this toolchain. And I think that approach is very healthy as well. And really wanted to highlight, hey, with the name, really want to highlight, hey, this is new and really good. In terms of compatibility and approach and the underlying tech and everything. Look, it's my fault. The main word I came up with is modern. But
sorry
the
to put you
compiler
on the
itself
hook.
on the oh yeah, I mean, look, lots of people have commented on this internally and that kind of thing as well. And look, our command line version of this is called BCC64X. And I don't know, maybe we'll rename the platform Windows 64-bit X or something by the time we ship. I don't know. I agree. I think we need a better name.
Elon Musk will swoop in like a hawk immediately and say, "Aha! It's mine. I like X." Yeah, because now apparently he owns the letter X for everything. I think. Yeah. Very cool. I mean, it goes back again to the enthusiasm of the people that work on this product, because I spoke to someone who was using this in a sort of trial situation without giving away too many NDA details, but they were super enthusiastic about it, and I think that's the general feeling of the people that I know who've had a chance to get their hands on sort of early versions and play with them. And bear in mind the safe harbor statement, but this is, it's an exciting thing. The version 12, when that came out, lots of people, C++ people, were very excited about what was possible, and this is another step forward as well. So, good stuff, and it's nice to be involved in happy things, shall we say.
Yeah, I think look, a lot of the feedback we're getting are about people who are compiling C++ code that they had trouble with the old toolchains, and it's just working now. And that's that's the kind of thing we're aiming for, and it's wonderful feedback. It's really nice for us to hear people saying, "Oh, hey, look, we're testing this out, and stuff that we had trouble with before, it just works now," because that's what we're going for.
Yeah.
So yeah, it's great to hear that.
Yeah, I saw someone mention in one group they tried out 30 projects and all 30 worked, and that was very, very interesting feedback to hear from someone who actually can be quite critical and has got every reason to be able to be, they're not scared of saying how they feel, put it that way, and so they shouldn't. I encourage people to email me all the time as the developer advocate. I literally give out my email to anybody and say, good or bad, if you think we're doing something wrong or you think there's something we can improve on, tell me, because we want Embarcadero to not look like some kind of big corporate faceless corporation where you don't know who to talk to, you don't know who to ask about these questions, or maybe there's something you really love about C++ building, you don't want us to get rid of that. Let us know, because at the end of the day, we exist because you use our products, and we want those products to be something that make your day better and improve your ability to work or whatever it is you're doing, studying if you're a student or something like that. So let us know, and ian.barker@embarcadero.com, email me, and we all give out our email addresses. We don't want lots of questions about, hey, this C++ bit doesn't compile, how do I fix it? That's not what we're there for. There is a support team for that. But we do want people to tell us if there's something they like or don't like, or, just suggestions of how we could have done something better. And if we can, of course, a good idea is a good idea. We will consider it and look into it. Can't promise anything, but, we don't want to create a product that nobody wants to use and everybody hates. And this is definitely, heading in the direction of a product that people want to use and that people love. So it's good.
That's
got
the
other
goal.
questions?
I mean, we really want it to be something that's so much outstandingly better that people just switch to it. Look, on the note of emailing about, hey, the C++ code doesn't compile, what do I do? in general, like as I mentioned, we're seeing a bunch of code that people had trouble with him before that works now. I think it's worth mentioning we have an internal bucket of issues with the old toolchains that we have marked for retesting against the new toolchain. Basically to see, look, these are a set of things where had trouble in the past, and we think the new toolchain will solve it, and we're seeing excellent results there as well.
Yeah, the big bucket of issues. I like it. Take an issue from the bucket. Yeah.
Look, it's in Jira. For those of you who use Jira, categorized via epics and via labels and stuff. We've just done this via label. We call it the Clang retest label.
Yeah, it's not an actual metal bucket, in case anybody's wondering, with lots of post-it notes thrown into it. Yeah, it's more complicated than that. Yeah, okay. Are there other questions you want to address, or do you think?
Yeah, there are quite a few. I'm afraid we're in a quarter of the way down, which is awesome. So thank you everyone for asking so many questions. I'll get through as many as I can. And as Ian said, email us, Ian or myself, or both of us together. I'm happy to answer. But look, the next question was about optimization of the output. So the question was that when switching with the old toolchain from 32-bit to 64-bit, it looked like the 32-bit toolchain was a bit smarter about what it linked. In other words, that the 64-bit compiled exe was larger. And the question is, will this happen with the new toolchain? So yeah, look, iLink 64 was, which is what the old Win64 toolchain uses, is not as smart about removing unused code as the 32-bit version of iLink. And so, sometimes too much was linked in, code that wasn't actually reused and run by your app ended up inside the exe. So the new linker for the new toolchain, obviously we're still evaluating a lot of this stuff, but it should be a lot better. We've actually been just looking in the past week at which settings to enable here. So there are about 3 different options that control how the linker processes the code that it's given and decides whether that ends up in the final exe. The one we're currently, all 3 of those settings we're planning to enable in the options dialog. So when you get this, when we ship this, you can experiment and use them. There's currently one that we're thinking of turning on by default, and then the other 2 are ones that can be really useful to cut out unused code and make your executable smaller. They can sometimes have side effects of making your executable slower. So we're thinking of including them there so that you can use them if you want to, but turning them off by default. That's just our current status, but definitely looking in this kind of area as well. And I think it's just worth noting in general, we expect the new linker in a variety of ways to be heaps better than our old linker. Look, there are a lot of comments actually, and I won't read out all of them, but a lot of comments about how this looks really good. And thank you. The credit goes to all our amazing engineering team. They've put in a huge amount of work and decisions. They're fantastic people. And also definitely. Really credit goes to our staff and management and the executives who are keen on this project as well. I'm really grateful for the support we have for this.
I always say as well, when people say about something positive, it is about teamwork. And as a relatively new employee of Embarcadero, not that new now, it's nearly a year now, but the one thing that really struck me when I joined up was how passionate everybody at Embarcadero is about the product and the customers and getting the right answer. If you ever deal with one of the SCs, which are our sales consultants, those people go out of their way to give the right answer and help people and things like that. But that's carried through to everybody: salespeople, marketing people, management, and engineering, and everybody plays their part, and it is definitely a team effort. you know, it's very gratifying to be part of that team. It really does help when everybody's pulling in the same direction.
Yeah, you're really right. I consider it quite an honor to be working among these people, including yourself, Ian. Look, we have some questions here about third-party components, and will they work seamlessly with the new Clang toolchain? So, look, the new Clang uses a new object file format, and so that means that we've had to change Delphi's compiler in order to emit that different format. So we're using COF, which is the de facto Windows platform standard. You've probably heard me use that phrase a lot, but really these are the choices we're making everywhere we can. And yeah, look, if you have Delphi components that you want to use from C++ Builder, today in the version that you have today, there's an option there for generating C++ object files, and we're extending that so that there's a setting to extend, to emit new C++ Builder object files. In other words, yes, any sort of third-party library that's written in Delphi, should be able to have a C++ Builder version of that exactly as you already do. I gave a long answer there instead of a short answer, probably because it's fairly late at night and I'm tired. The answer is yes.
Yeah.
There's a question as well.
I don't think people appreciate quite how late at night is for you there. You are doing very well to stay up.
Oh, thanks. But look, actually, I mean, the webinar is really exciting. I'm just so happy to present what's coming. It gives me a bit of adrenaline and energy.
Cool.
Look, there's a question here that digs more into the details, which I think is really good because trying to really share a lot of the underlying tech here in this particular talk. And the question is about BPLs. So we mentioned that creating packages and consuming dynamic packages is not ready yet. And it's just worth adding, look, that'll come. I mean, working on it. Don't know what point that will come in, but of course it will arrive at some point. And the technical question was that the old 64-bit compiler had a problem with packages with static class members and global variables. And will the modern compiler have that kind of problem? And look, obviously I can't exactly answer yet because we're still working on that. But I can tell you that we're actually using a different technique for packages, most likely. I'm hand waving here because this is still something that we're developing on and isn't finished. Look, the packages can be quite complex because they're really a Delphi idiom that we've kind of mapped to C++, and it doesn't fully map to how C++ works and thinks. But and that affects some things in how a package is loaded and initialization of units and availability of global variables and when they're initialized and that kind of thing. And the old linker ilink wasn't perfect in this. Sometimes it made guesses. So we're looking at a different technique now that we hope will mean that when you dynamically link to packages, you get the same initialization behavior as when you statically link. And having exactly the same behavior is obviously a really good thing. So look, I'm hand waving here because this is still something that's in really active development, and I don't know even when it's going to arrive. But hopefully, yes, it'll be a lot better and a lot more robust than the old version. Full of caveats there, of course, because it was current status. But look, in general, I really want to communicate as something of everything sort of being done with an eye to being better, and I think this is one of those areas too.
Yeah, I think it's one thing that people ask us about as well, which is we get people ask about roadmaps all the time, and this is not IDEA's policy. We are an IDEA company. They choose not to have roadmaps. and in fact, there are lots of reasons why they don't do that. They have some complicated kind of outside pressures on not making forward-looking statements and things like that. But these kind of webinars where you have made sure that what you're about to say is okay with legal people and things like that. But it does seem to be something that people want, is to have some idea of the the work that's going on, to be a little bit more open as far as we're able to, with some caveats, and say, look, most of you people, if not all of the people on the call, are developers, and everybody knows that development is not an exact science. It is part science and part art. And sometimes your best intentions, no matter what you're doing, it doesn't work out. And so, we can't always, a feature looks like it's done and it's working and everything's fine, and then something right at the very last minute, happens to prevent it. So, it's why we have to be a little bit cautious when we say this is what we're going to do. And really what we're trying to say is this is what we really want to do, and we're doing our best to make that happen. I think that caveat is important, but I think people understand where we're coming from. So
yeah, look, just continuing down the list, there's a question here. The question is about having issues using an array of variant, which is a Delphi type, and whether that's working. Look, I would have to look that one up specifically, but we have tests for all of these things, and so far as I know, they're all our tests are passing. Variants are a particularly tricky one, and I actually remember a couple of weeks ago seeing some code go in that handled that specifically. So yeah, I mean, look, in general, Delphi drop should work well.
cool.
Look, there's a question about when packages support is expected. Look, just to clarify, you can if you have C++ code you're building in a package right now, you can build that as a library and link it. It's just statically linked. Yeah, so look, dynamic linking is something where we're still working on, and I can't really answer that. That's not because I'm not allowed to answer that. It's just that we're still working on it, and I can't give you an answer. But obviously it will come. When we ship the first version, we may have static linking of packages, which would mean that your executables are a little bit larger than normal. But on the other hand, the main reason for using dynamic packages was speed, and the new link is about 4 times faster. So hopefully that's not an issue. Whatever we end up doing, dynamic packages are coming, for sure, and we're actually working on them right now. So hopefully that's a good answer. It's the best answer I can give. Yeah, definitely coming.
Yeah.
There's a question here about will we be able to use open source libraries like OpenCV? I don't think we've tested OpenCV internally yet, but look, in general, the answer for all of these is that the new toolchain is a lot better at being compatible with standard open source C++ libraries. It's hugely better. So my answer is take a library like that, throw it at the compiler, and see what happens. Everything we've tested so far has worked really well. Sometimes you might have to change a header if it's coded to assume it's compiling for Visual C++ and has a nifdef, for example. But in terms of all the C++ code, our goal is it will if it compiles with anything else, it'll compile with this. So yes, you should be able to take any library and have it work.
Cool. I'm going to address a non-C++ question just because it's one that's come up quite a lot. Giuseppe asked about what about the QA portal. Look, I know Marco posted a blog post and said it'll be ready in 2 weeks, and then it wasn't. And it's just taken a lot longer than we expected. We have migrated the QA or the QP actually, the quality portal. we're trying to get it up as quickly as we can. There have been some issues that we brought up and they're being addressed. It is being worked on by a dedicated team, not anything to do with IT or internal development, but actually specific people that's what they do, and that's being dealt with at the moment. So the answer is, what about the new portal for the quality assurance or the QP? It's coming. I'm sorry it's not ready yet, but it will be as soon as we can get it up there. We know you want it, but it's a migration rather than a problem with the server or anything like that. We had to move from what we were using before with Atlassian to something very different, and we want to make sure it works before we actually turn it on, and it's not quite working properly at the moment. Okay, David, are you good to answer more questions, or do you think we've covered the ones that we've covered? Or
look, a whole heap more have come in, so I see about half as many questions again that we actually haven't answered in text yet, because they came in since we started the Q&A. So look, I will try and get through as many of these as possible. And look, if I'm scrolling through hundreds of questions here, by the way. So if you have written something in and we haven't replied via text, or we don't address it in the Q&A, please email us. And we would love to hear from you.
I will actually save the questions log as well, so that we've got that questions log that we can look through as well. We do try and answer as many as we can, but in fact, there is one that we probably should address, and that is from David into Simone. So David I. And he's suggesting,
wonderful.
Yeah, David is always there. David just supposed to have retired. But he's David I, as I'm sure most people know, was developer relations long before that term even really existed, and a great guy. And then his question, or in fact he's suggesting, I might suggest changing the modern compiler target text qualifier to match with the toolchain being used under the covers. For example, uses Clang 15.0. Yeah, there's been a big discussion about the word modern, which is why I asked that question earlier on. But yeah, I don't think that we've hit on the answer that everybody agrees on yet, but we'll get there. Okay.
Yeah,
well,
it's a really good idea to use that though. The thing is that name might change quite fast, because we're currently using Clang 15 because that was what was current when we started the upgrade, and you don't want to sort of switch targets halfway through. But after we ship, we're going to want to keep on staying up to date. So yeah, we might have Clang 15 in 12.1 perhaps, and Clang something else in a future release.
Yeah,
So
I mean, I've heard arguments for and against all sorts of options. So, I think the more suggestions, the better, because I think something will bubble to the top that makes sense. But yeah, it's a good idea. I mean, definitely something that doesn't say modern seems to be the sorry, David, but it seems to be the popular choice, is to actually come up with something that's a little bit more kind of generic and less tied to C++, modern C++ terminology that is used in the C++ standards. So yeah, cool.
Yeah, definitely something we need to improve. And David, look, first of all, it's really nice to hear from you, and hello. And second, that's a really good idea.
Yeah, he's always around. He quite frequently is at their webinars, but I think this is one that is particularly close to his heart as well, I'm sure. So I know he's a big C++ fan. He actually interviewed Jan Strustrup as well.
Fantastic. Look, I apologize, but I want to keep on going on with questions, just because another 50, I think, have just come in. So look, the questions here about CodeGuard. Will there be CodeGuard support for the new toolchain? So yeah, currently CodeGuard is for the classic compiler only, and we don't currently have an equivalent for the current Clang toolchain, but of course we want to. And look, Clang has this wonderful set of features called sanitizers, which effectively achieve the same things as CodeGuard. And what we want to do is enable those for the new toolchain. Look, one of the main reasons for upgrading, as well as obviously staying up to date and current and platforms compliance and language compliance and all that kind of stuff, is that the new toolchain will let us do a lot more things. One of the things we want to do is enable sanitizers. So that won't be in version 1 when we first release, but it's definitely something we're going to be looking at doing, and I would really like it because I definitely want to have sanitizers which are effectively code guard for Clang. Yeah, that's a definite strong internal goal that I would like to get to as soon as possible. There's a follow-up comment from that allowing sanitizers would be a game changer, and yeah, I absolutely agree. Yep, definitely really strong internal goal. Definitely want to do it. So there's a question here about C++ 20 features like std format. So when we ship our officially supported version, will be C++ 17. And again, one of the reasons for that is just sort of not changing the goalposts halfway. Currently ship with C++ 17 support, and we're doing an upgrade, and we just wanted to keep the same standard. But of course, the compiler and the RTL and STL support language features that are newer than C++ 17. So look, it's unsupported, but you can pass in the -std equals C++ 20 or 23 flag and experiment. So look, we haven't tested with std format, which is in, I think, C++ 20, but the format library, like squiggly bracket FMT, close squiggly brackets, works well as far as I know. Yeah, I think either of those are something you could use. You can either use that library or just experiment with changing the the language compliance parameter that we pass in. We're obviously going to be looking at increasing the officially supported version in future. As I said, it's just a matter of not doing too many things at once. But yeah, experiment and see what happens. There's a question here about if there'll be 64-bit COF library versions of Delphi components distributing GetIt, and what happens with DCC 64. Look, the Delphi compiler has been extended so that when you have the settings to emit C++ builder object files, you'll be able to emit the object files for the new Clang as well. So we're doing that for all the packages that we sort of listed in that big table earlier. And yeah, look, for things on GetIt, it depends on who provides them, but yeah, no, they should work. Yeah, GetIt is not something I'm hugely familiar with, and if you compile via source though, which most of our GetIt things do, they have a project file and then you compile it and install it. What we'll do is just change the project file so that it also emits the new version for Clang. Should just work.
Yeah, it's usually tested, through the whole loop to make sure it will work. And if it doesn't, then they go back to the supplier and say, hello, this has got a problem, here are the problems, and someone sorts it out after that. So someone mentioned here, because this is kind of a big news in the C++ world, really, which is that the White House is saying, oh, you shouldn't use C or C++ because it's not considered memory safe, which is interesting. But I think that they're suggesting that some languages might be more memory safe, and Rust was one of them. But weirdly enough, the other language that they did mention that was memory safe, or they consider memory safe, was Delphi. So it's one of those things that I hear what they're saying, that they're saying that some languages are potentially hackable. But that's been true of languages for decades. I mean, you should use things like static code analysis and SAST and stuff like that to check your code anyway, and to make sure that if you're going into an environment where you are concerned about security, and most people should be, then using SCA and SAST, and also composition analysis, which is a similar thing as well, where you check that the components that you're using are also safe and free from vulnerabilities. It's such a big subject that our recommendation is to use an outside tool to do it, because it's a moving target, just the same as antivirus is a moving target. You know, just when you think you've got an antivirus that stops everything, then, you know, out comes a new type of virus, and a lot of these state-sponsored actors now that are doing these things as well. So John Patrick says, John Oldfield says, what's wrong with non-memory safe programming code? It's a White House thing. It's just a big story in the news at the moment. The White House are covering their basis, but you know, we've got a number of partners that provide static code analysis and stuff like that, and it works with C++ and with Delphi as well, ones that we recommend. So just go onto the blogs and look there. We've got lots of webinars about it and videos and things like that as well.
Yeah, look, in terms of memory safety, I mean, it's just that C++ is a very flexible language, and you can write memory unsafe C++, but you can also write very well structured and very safe C++.
Yeah, so, and the tools, the analysis tools help make sure that you're not, you know, you can look at a piece of code and be perfectly satisfied with it, and then some of these tools will come along and say, oh, this is wrong, and you think, oh, it never even occurred to me that this would be a problem. It's quite remarkable the ways that people can exploit all sorts of programs.
Look, a few more questions. There are some about dynamic linking and asking when. Look, I mean, basically the same answer as I gave earlier. I would give you a solid one if I could, but I really don't know, because what we're trying to share in this webinar is where we are currently, you know, today. And the status today is that we're working on it today, and it's not finished yet. So, you know, the best answer I can give there is, you know, look, it will come. We know it's important, and it will arrive. The few questions about other platforms such as Linux, and I think the best thing there is just that, look, we're just trying to get the new Windows out right now, but the new Clang is a foundation. It's a foundation for many things. You know, it'll let us do many things. You know, even things like the sanitizers that we discussed earlier, for your runtime code safety and checking, you know, is something that we want to do, and that the new Clang, you know, opens up the possibility of doing. And yeah, the new Clang opens up the possibility of, you know, it's a foundation that will enable us to go to other platforms if we choose. But yeah, right now we're just focusing on Windows. So we don't have anything else to announce there.
Yeah, it's a significant step forward. Is the thing? It's a big change. It's not something that could just be, you know, a button clicked and then everything works fine. There was a lot involved, and a lot of work went on behind the scenes to make it happen. And you know, I think you'd expect us to take our time and make sure it's done properly before we just go off and do everything and go, there you go, it's ready, off, leave it, and everything falls to pieces. We're trying to avoid that. And as you said, you know, the new Clang or CLang is a foundation. So, you know, getting there, but nothing to announce, unfortunately. Sorry about that.
There's a question here about why we chose to add the new Toolchain as a platform rather than in the options. And so for Win32, toggling between the classic compiler and the Win32 Clang compiler is a setting in the options. It's not a new platform. So the question is, why haven't we done the same thing here for Win64? That's a really good question. And I hope you'll forgive me explaining this in detail, but it's quite interesting. So yeah, for Win32, I'm not certain if we did the right thing there, because it can be a bit confusing actually, but in essence, they are the same platform, but just a different compiler. So they both use the OMF object file format, for example. So under the hood, you know, in terms of what they generate, you know, they're different compilers and so forth, but they are similar. Whereas the Win64 one is actually completely different. And although we think of a platform as something like, you know, Windows 64-bit, a platform is, you know, has a whole lot more. You know, it's the set of you know, the object file format and, you know, the STL that we point at and the debug format and that kind of thing. And this new toolchain is completely different, completely new for all of those areas compared to the old Win64 toolchain. There's nothing duplicated. It's completely new STL, for example, and a new linker and different object file formats, and everything is different. And for that reason, it really is a new platform, because deploying to it and building for it is completely new and different. So just at a technical level, that sort of made sense to present it as a new platform. And just under the hood, it actually made it easier for us to build it as a new platform, because it really is. And the second reason is that we also want to make it really easy to switch to this, to upgrade your projects away from the old Win64 to the new Win64. And look, in the past, when we've delivered a compiler upgrade or something, it was delivered as a replacement. But when upgrading, sometimes you want the old and the new sort of in parallel, side by side, because it can make it easier. You go back to the old one to check something, and then toggle back to the new one to work on something like that. And so shipping them in parallel, so that you have two platforms, and you can just, in a project, just double click the platform and change between which one, is intended to really make it smooth to upgrade. So those are the two reasons, both the technical underlying that, in essence, it really is a new platform, and also the ease of use and trying to help you out to make it as easy as possible to switch. Those are the two reasons why it's presented as a new platform. There's a question about which third-party or open source libraries we've tested the compiler or linker with. Golly, quite a few, and my mind is going blank right now. I know one of our engineers told me that they were building Skier, for example. But yeah, look, we have a whole bunch of code that we're running internally and testing internally. And I'm sorry right now, I just can't remember, but quite a lot. There's a question here that's important to highlight important to highlight the debug format for the new toolchain is PDB, so that you could use WinDebug or IDE Pro for debugging. Yeah, look, that's a really good point. We haven't tested these third-party debuggers, but again, one of the reasons for when making the technical decisions, I mentioned that we went back and reevaluated all of our decisions and tried to take a really new, modern approach, one that really fitted in with how it's done on Windows in general. And Windows uses the COF object file format, and and that means there are a lot of other tools that handle COF that we hope are going to be able to be used with C++ Builder now. And the debug info format is similar. We're not officially supporting a third-party debugger like IDE Pro, but we're using the same debug format, and hopefully that will open up a whole set of extra tools that can be used with C++ Builder.
Yeah. One of the questions there, where I can't remember whether you answered this or not, but I think I know the answer, which is, will COF and PDB support also come to 32-bit? I think the answer at the moment is that it's 64-bit only. Is that right?
Yeah. So look, when we ship this, it's going to be for Windows 64-bit, Intel x86, and once we get that out, we'll be looking at where we go after that. Do we go for Win32, or I don't know, maybe we go for Win64 ARM, or maybe we go for something else. We haven't decided that yet, and we're laser focused on delivering this so that you can use it for Windows 64-bit first. And there are a few reasons to go for Win64 first rather than Win32. When we initially upgraded many years ago now, Win32 was always first. But look, in 2024, Win64 is where a lot of people are. It doesn't really make sense to deliver Win32 first when everything is 64-bit these days. And a lot of our customers have upgraded to 64-bit and want a 64-bit compiler, and so that makes sense as the first one to go for.
I think that's true as well. Much more of C++ than Delphi. because I think that, you know, there are plenty of Delphi programmers who still, you know, build for 32-bit, but for C++, it seems to be quite often that people are much more likely to be building 64-bit executables. I don't know why, but Delphi, you know, it's common to see people are just using 32-bit all the time. So.
Yeah, well, there was a question in the question log which I haven't directly answered because I'm scrolling through so many, and I apologize. I was talking about someone who really wants this for 32-bit because they have problems upgrading their code to 64-bit. And so yeah, 32-bit definitely remains important. We have seen a lot of people upgrade though, and yeah, although it, you know, depending on your code base, you know, can be tricky. We do sort of encourage that because you know, 60, like just talking about Windows itself or the development space itself, 64-bit is where, you know, where things are going forward. You know, 32-bit is, you know, not where anyone's attention is, you know, even Microsoft's. So yeah, would definitely encourage looking at the 64-bit for your apps in general.
Yeah, I know some server admins who actually will not run anything that isn't 64-bit. Because they, you know, that's their policy. I don't know whether that will spread as time goes on.
Oh, look, I think it'll become more and more common. I think, you know, things are moving very heavily in a 64-bit only direction within the industry in many ways.
Yeah, I mean, the arguments I saw for them doing that were a little bit specious, but I do get where they're coming from.
There's a question here about can we link in libraries without needing to run coff2omf.exe. And so, yeah, coff2omf is when you have an existing library that's in coff object file format and you need to convert it to OMF, which is what our 32-bit Clang uses. Our 64-bit, our old 64-bit used ELF. And yeah, look, the new Win64 toolchain uses coff as its object file format. I do want to just clarify here that, you know, when you have a coff library, if that's an import library, you know, an import library for a DLL, which is very common, someone will ship a DLL and import library so that you link it in. Yeah, that should hopefully work. If it's just a coff object that's been compiled by some other C++ compiler, then the best route is to recompile it with C++ builder, and yeah, that's what we're focusing on, making sure that's easy. But yeah, you know, the new object file format we're using is coff. In general, you should never try to compile object files built with different C++ compilers together. You know, no matter whether it's C++ builder and something else, or, you know, Visual C++ and something else. It's a recipe for all sorts of trouble, both at link time and runtime. So if you're just linking in code, just recompile it. You know, we're trying to make that really easy. But if it's an import library for DLL, yeah, just, you know, hopefully just link it in. Let's see, I am scrolling through things. There's a question about data snap. Look, it's not that it's not being migrated to the new toolchain, it's just that currently here we are in February. It's not one of the libraries that we have you know, rebuilt internally. Look, we have, I don't know, 110 different packages or something, and yeah, we really wanted to keep our testing matrix under control and focus on the core libraries. That's why DataSnap wasn't one of them. It was more important for us to test with all our VCL libraries, for example, yeah, because they're so widely used. But yeah, look, at some point, everything will be enabled and rebuilt, and of course, you know, we generally ship with source, and so, you know, you can add stuff and rebuild it if you need. You know, I'm not sure when we ship 12.1 if you know, our DataSnap package will be enabled for the new compiler or not, but you know, there'll be ways around that. But what I'm trying to say is, look, it'll come at some point, so don't worry about that. We'll be enabling everything. We're just trying to keep, you know, it's a big amount of work, and we're concentrating very thoroughly on our testing and our quality, and you know, we're trying to keep our test matrix under control and test on the most commonly used and most widely used packages and libraries first, and expand second, and we will expand. Let's see. So there are many dozens of questions, and look, I think many of them are around topics that we have already answered. So questions about the naming, for example, and that kind of thing. Are libraries that taught on the 64 versus 32-bit thing. There are many libraries that are actually only being shipped by the library vendor as 64-bit these days. That's also a good point. I mentioned that our compilers, by the way, Red Studio itself does not support being installed on a 32-bit version of Windows. You might be able to get away with it and have things mostly work, but it hasn't been supported for several years. You have to install on a 64-bit version of Windows, which is what everything is these days. But the new toolchain, the new Clang, the executable, the compiler executable itself is a 64-bit executable, which has massive benefits in terms of memory. Just a couple of days ago, our QA was testing something that failed with one of our old 32-bit compilers because it ran out of memory, and of course it works fine now with the new toolchain. But yeah, look, everything is moving to 64-bit, including us. Well, there's someone commenting that their product became 2 times faster using the 64-bit compiler. Well, that's nice to hear, and hopefully the new toolchain will be faster still because much newer version and has more optimizations and so forth. Cool. Yeah, a lot more comments about people using 64-bit instead of 32.
Yeah, a lot of people saying that they always use 64-bit and not 32-bit. Yeah,
look, I think the feedback that we're getting, because there are about a dozen things here that have just come in the past 2 minutes, are all emphasizing that we made the right choice of delivering Win64 as the one that we're aiming for. So that's good to hear, and I'm glad to read that feedback. Thanks for writing it in.
Yeah, and I have just to emphasize, I have saved the questions log, so we can answer some of these. There'll be one of the questions was asked. They said, oh, they missed a certain part of it. There will be a replay. We always put the replays up on our YouTube channels, and this one will probably appear in the IDE as well. I'll make sure that it appears in the Learn section there. And we always do a follow-up blog post as well to explain for those that didn't necessarily catch, because I know not everybody that's watching English is not necessarily their first language, and David and I speak relatively clear English, but we do speak it quite quickly sometimes, and I know that can be a problem for some people. So the blog post will be there with the slides as well, and the replay. So if there is something you've missed, don't worry, you will be able to catch it. We want you to know this information. We don't want to go, sorry, you weren't around. Tough, you've missed it. No, we're trying to make sure that people are kept informed. And some people register for the webinars just because they know they can't make it on the day, but they know that they'll get notified about the replay, and that will happen in this case as well. So David, I think we'll probably call it a day for now, because there are just so many questions. We're going to be here for a month of Sundays answering them all.
It has run for an hour and a half now, but I think we've answered, like, I tried to pick representative questions when people are asking about similar sort of things, and try to answer as many questions with one answer as possible.
Yeah.
But yeah, do email us if you want. And look, this is as a behind the build, it's sort of a behind the scenes look as where we are today. And yeah, look, we're looking forward to when we deliver, when we ship, which I can't comment on, but this is really exciting. I'm really enjoying using the new toolchain, and just all the feedback we're getting about stuff that's working really well with it is encouraging. Just want to get this out to you as soon as possible.
Yeah.
So yeah, looking forward to when we do that, which isn't announced, but hopefully fairly soon.
Yeah, and I just remind everybody again about the safe harbor statement. These are not promises; these are things that we're aiming to do, and we do our best. to try and deliver what we can, but until the GA of any version is released, things are subject to change. It could be for lots of reasons. Sometimes I know people don't agree with the reasons, but that's the way. That's software development. That's the market. That's the prevailing things that go on. Something random happens. Just bear in mind the safe harbor statement. But this is what we're trying to do. We are trying to, behind the build, is to allow you to sort of peek behind the curtain a bit, so that we're not some kind of mysterious black box where out comes some kind of application and everybody's surprised. It's all good. Okay, all right. Well, I'm going to call it a day, David, unless you've got any final words that you would like to put out.
Look, I just want to thank everyone for attending. The webinar's run for an hour and a half, a good hour of that being the Q&A so far, and we still have almost everyone online, and an awful lot of really awesome feedback, and I think a lot of people are very excited. So thank you everyone for attending. We're really excited as well. Just looking ahead now to getting this out to you, and that's going to be a really exciting day.
Cool.
So thank you everyone.
I echo that as well. Well, thanks everyone, and we'll see you around next time. Bye-bye.
All right, goodbye.